Hello everyone, welcome all to this new video. In this video we are going to discuss about oxidations. Okay, I know you are familiar with oxidation reactions. Firstly, what is the definition of an oxidation reactions? There are many definitions for oxidation reactions, which one of which is during a reaction when the electron is lost from a species, that reaction may be called oxidation reaction. Or when oxygen atom is added to a species or a molecule, it may be called as an oxidation, or removal of hydrogen may be called as an oxidation reaction. In this video, we are going to discuss about the oxidation reactions of alcohols. Alcohols oxidized to aldehydes or ketones, and maybe the aldehydes further oxidized to carboxylic acids. Okay, for example, a general oxidation reactions of alcohol be like this. Consider a molecule. This is the molecule R, CH, CH, CH. This is an hydrocarbon, an alkene, which on oxidation with a suitable reagent, it undergo oxidation reactions and form RCOH, HH. This is a primary alcohol. Okay, this is a primary alcohol. So this primary alcohol on oxidation, on further oxidation with a suitable reagent, it gives you RC double bond OH. That means is an aldehyde. Okay, this is an aldehyde. We can further oxidize this aldehyde into this on oxidation into this gives you RC double bond OOH. This is an acid, carboxylic acid. Okay, carboxylic acid. So you can see here this hydrocarbon on oxidation gives you a primary alcohol. This primary alcohol on oxidation gives aldehyde, and which on oxidation gives the aldehyde, which on oxidation gives the carboxylic acid. Here you can see that here in this compound there is no carbon oxygen bond. You can never find a carbon oxygen bond here, but in this compound there forms on oxidation of this compound, this primary alcohol is forms, there is a one carbon hydrogen bond. Okay, there is a carbon oxygen bond, not hydrogen, carbon oxygen, single carbon oxygen bond is formed in this primary alcohol. Then this primary alcohol undergo oxidation to form aldehyde, where two carbon oxygen bonds are formed. That means carbon double bond O. That means there is two carbon oxygen bonds between in aldehyde. That means there is two carbon oxygen bonds in aldehyde. Then which on further oxidation gives carboxylic acid, where 1, 2, 3, 3 carbon oxygen bond is formed. So when we start from this alkene, it forms primary alcohol, this and then aldehyde, then carboxylic acid, the number of carbon oxygen bond increases. Here only single, here 0, here 1 carbon oxygen bond, here 2 carbon oxygen bond, here 3 carbon oxygen bond. So we can say that when the carbon oxygen bond or the bonding to oxygen increases during oxidation reactions. Then another example, consider this compound R dash H. This compound on oxidation gives RCOH R dash H, which on further oxidation gives RC double bond O R dash. Okay, this is a secondary alcohol. This is a secondary alcohol, and this is a ketone. This is a ketone. Okay, you can see that this compound on oxidation with a suitable reagent gives a secondary alcohol, which on oxidation gives a ketone. this ketone may undergo further oxidation in harsher conditions, may undergo oxidative cleavage. It cleaves. Okay, so here you can see that here one only, here no carbon oxygen bond, 0 carbon oxygen bond, here 1 carbon oxygen bond is present, here 2 carbon oxygen bond is present. You can say that they undergo oxidation reactions. So this is the general oxidation reactions of alcohol, where primary alcohol gives first aldehyde, aldehydes on further oxidation gives carboxylic acid, and secondary alcohol gives a ketone as the product. So this is the general mechanism or general reaction of an oxidation reaction of an alcohol. Next we are going to consider some reagents which helps the oxidation of alcohols into carbonyl compounds, that is aldehydes and ketones. First reagent we are going to consider is, that is dimethyl sulfoxide. Okay, you can abbreviate it as DMSO. The structure of this DMSO is like this: dimethyl sulfoxide, okay, or CH3S double bond O CH3, these are equivalent, and it may be like this: CH3SO CH3 S plus O minus. Okay, this is DMSO or dimethyl sulfoxide. This dimethyl sulfoxide is a oxidizing reagent for alcohols to carbonyl compounds. What is the mechanism of this oxidation? We are going to check the oxidation, the mechanism of that oxidation. For that, first this DMSO should be activated. Okay, for that there an electrophilic molecule first reacts with this DMSO, dimethyl sulfoxide, which activates the DMSO. That means the electrophilic molecule activates the DMSO, and it on reaction with alcohol gives the product as carbonyl compounds. First we are going to check a general mechanism of DMSO oxidation. Firstly, DMSO, that means CH3 twice S double bond O, or you can write like this: S plus O minus. Okay, first reacts with an electrophilic molecule. Okay, any electrophilic molecule. Okay, and this attacks here into this oxygen. Firstly it attacks in the oxygen, and in the first step they forms a compound CH3 twice S plus OE. Okay, this electrophilic molecule attached to the oxygen. And the next step, the alcohol comes. Okay, the alcohol, okay, RCH2OH. Okay, this may be the alcohol. Consider this alcohol. This alcohol, it attacks this one, okay, to the sulfur atom. Through this oxygen, this bond cleaves and this bond moves towards this one, and same time this bond moves like this. Okay, so this bond cleaves, there a new bond forms between this oxygen and this sulfur atom, and this bond, this OH bond cleaves and forms the product CH3 twice S plus. Okay, the positive charge never cancels because one species lost from here, one species attached from here. So this oxygen attached to the sulfur, so O, then CH2R. Okay, this oxygen attached to here, then CH2R. Then this species is eliminated. Then in the next tube, a base removes one of the proton from here. Okay, this CH2, that is H and H, one of the bond cleaves and this bond moves towards this one. Okay, so C double bond O, this bond becomes C double bond O, and at the same time this bond cleaves. Okay, this bond cleaves, this bond cleaves and there forms a C double bond O. And lastly, the product will be like this, RCHO. Okay, RCHO, C double bond OH. So that is RC double bond OH, an aldehyde, plus this is CH3 twice S. Okay, this compound is formed as the product. Okay, you can see here it is this is a carbonyl compound, is an aldehyde. This is an aldehyde. This is the product formed here. This is a general mechanism of DMSO oxidation. Some electrophilic molecules activates this DMSO in the first step. This is the activated DMSO and it attacks the alcohol, and this alcohol forms the aldehyde or carbonyl compound as the product. So this is the general mechanism of DMSO oxidation. Next, we are going to check what are the possible electrophilic molecules suitable for this attack. Okay, what are the possible electrophilic molecules involving in this DMSO oxidation? The possible electrophilic species that involved in DMSO oxidation will be, that is the electrophilic molecules. Okay, electrophilic species that involved in DMSO oxidation may be, first one, dicyclohexyl carbodimide. Okay, carbodimide. This is the one of the compound that involved in DMSO oxidation. This act as the activating agent. The structure of this compound will be like this: C double bond N, double bond N. There is 2 cyclohexyl rings. Okay, 2 cyclohexyl rings. So dicyclohexyl carbodimide. Okay, carbodimide is the first possibility. Then another one is oxalyl chloride. Okay, oxalyl chloride is the structure of oxalyl chloride is like this: COCl twice. The structure of this compound may be drawn like this: COCl. Okay. Then the third possibility, the third one we use is, that is acetic anhydride. Acetic anhydride we can use as electrophilic molecule is used. It can be used CH3 this is acetic anhydride. And the fourth possibility is SO3, sulfur trioxide, also can be used as the electrophilic molecule in the oxidation of alcohols to carbonyl compounds using dimethyl sulfoxide or DMSO. Okay, these are the some possibilities or some choice for electrophilic species involved in that reactions. Next, we are going to study about the DMSO oxidation of alcohols using DCC. Okay, using DCC, that means dicyclohexyl carbodimide. Okay, then in the first step the activation of DMSO occurs using this dicyclohexyl carbodimide, that is C double bond CN. This is the dicyclohexyl carbodimide, CH3 twice SO minus S plus. In the first step, this is DMSO. In the first step, it attacks this carbon and this bond goes like this towards this nitrogen. Okay, and you must remember this step is catalyzed by an acid H plus. This first step of this reaction is catalyzed by an H plus, and here forms an intermediate like this. This NH attached here, then is C double bond N, this one, and to this carbon there attached this oxygen, then S plus CH3 twice, CH3 twice, okay, CH3 twice. So this DMSO becomes activated. In the next step, the alcohol comes, okay, the alcohol be like this, RCH2OH, any alcohol, okay, this alcohol comes and it attacks here, okay, it attacks the sulfur present here, and this bond goes like this and this bond goes like this, okay. Then what happened is, here the bond cleaves, here the bond cleaves, and here C double bond O forms. Here this bond shift towards this one, they attach an H plus ion, then forms a compound like this, NH, C double bond O, NH, okay, here NH, that is NH plus attached to this hydrogen, okay, NH. This group eliminates, this compound eliminates, okay, this compound eliminates, plus there forms another compound, this one RCH2, RCH2O. This oxygen is attached to the sulfur and CH3 twice, okay, CH3 twice, and one H plus ion from here it leaves, so this bond cleaves and this oxygen attached to this sulfur atom, and this bond here, this bond cleaves, okay, then forms this one RCH2O, SCH3 twice. In the next step, a base abstract a proton from here, okay, abstract a proton from here, here two protons, a base can abstract one of the proton, and this bond moves towards this one and this bond cleaves, okay, this here is an S plus, okay, here S plus, then this bond cleaves and forms R C H double bond O plus CH3 twice S, okay. This will be the mechanism of dimethyl sulfoxide oxidation using DCC, dicyclohexyl carbodimide. This reaction is known as Moffatt oxidation, okay, Moffatt oxidation using DCC, the oxidation of DMSO alcohols using DMSO and DCC is known as Moffatt oxidation reactions, okay. Once more, in the first step, this DMSO, that means dimethyl sulfoxide, is activated using DCC, an intermediate compound is formed here, and then the attack of this alcohol takes place, this oxygen attacks here, this bond cleaves, and here this bond shift like this, and this molecule eliminates, and then the remaining molecule is RCH2O, SCH3 twice, S plus CH3 twice, then a base can abstract hydrogen from here, then this bond moves towards this one, this bond cleaves and form the aldehyde as the product. This oxidation is primarily used for the oxidation of primary alcohols to aldehydes, okay. Primary alcohols to aldehydes is a very important oxidation reactions of primary alcohols to aldehydes. This is known as Moffatt oxidation reaction. One of the example for this Moffatt oxidation or the oxidation of alcohols to carbonyl compounds using DCC and DMSO, okay, dimethyl sulfoxide and DCC is one of the example is like this, okay. This is OAC, then there is an alcoholic group, is a OH alcoholic group, then O, then O, C double bond O, okay. Then this on reaction with the DMSO, dimethyl sulfoxide, and dicyclohexyl carbodimide, the product will be, here is an alcoholic group, is a primary alcoholic group is here, which is oxidized to aldehyde. So the product is like this, OAC, then O, then C double bond O, here CHO. This is another example because this alcoholic group is converted to the aldehyde group using DMSO and DCC. Another example will be like this. OH is present here. S. Okay. Then here COOCH3. This one reaction with the DMSO in presence of DCC. The product is here the alcoholic group converted into the aldehyde group, and this will be the product. Here aldehyde CHO, then double bond COOCH3, here sulfur, okay, dimethyl group. Okay, this is another example for this Moffatt oxidation, or the oxidation of alcohols using dimethyl sulfoxide and in presence of DCC. Okay. In this video, we discussed about the oxidation reactions of alcohols to carbonyl compounds, especially using DMSO, that means dimethyl sulfoxide in presence of DCC, known as Moffatt oxidation reactions, with an example. Next, in the next video, we are going to discuss about some more oxidation reactions using DMSO, that means dimethyl sulfoxide in presence of oxalate chloride, then acetic anhydride, etc. that we are going to discuss in the next video. So we can wind up this video here. Thank you.